If you're going to use a theoretical distribution, either to find a critical value to then eventually compute a confidence interval or to compute a p-value, the natural question is when to use the normal distribution and when to use the t-distribution. Generally, for anything that has to do with a proportion, use the normal distribution. For anything that has to do with the mean, use the t-distribution. This test involves a proportion, so you would use the normal distribution here. It's a one-sided alternative because of that less than the alternative hypothesis. We've got the p-hat from which we can compute the test statistic rounded to 4 places that ends up being negative 0.3457. To compute the p-value in StatKey, the option you want is normal under theoretical distributions. Normal because this has to do with a proportion. So if you look up in the upper right corner, the default is to have a standard normal distribution with a mean of 0 and standard deviation of 1. If that's what you have, then you can just use the test statistic as the cutoff and that will give you the p-value. So we had a less than in the alternative hypothesis, so we need a left tail, and then we just have to change the cutoff to negative 0.3457. And there's the p-value, 0.365. StatKey will only accept the cutoff written to 3 places instead of 4, but that's really about all that you have to do. You just have to specify which tail you want and the cutoff, and that's it. If you were going to use the sampling distribution as the reference distribution, again you want normal under theoretical distributions, but now I have to go in here and change the parameters. So I want a mean of 0.3 because that's what's in the null hypothesis, and I want a standard deviation of 0.0447. That's what you get if you round the standard error to 4 places. It'll still be a left tail, and then we're going to have to use p-hat as the cutoff. To 3 places, p-hat is 0.284. And you get a p-value of 0.36, which is a little bit different than what we got the other way with the standard normal as the reference distribution and the test statistic as the cutoff. The only reason it's a little bit different is just rounding. But that would also work. That option does exist for proportions. Most people just use the test statistic as the cutoff for proportions because that's what you have to do with means. That's probably the simplest way to do it, but this is also an option if you wanted to do it this way. The next example is a two-sided alternative. That's really the only thing that's different here. This involves a proportion, so it's still going to be using a normal distribution. So when we go to StatKey, under theoretical distributions, we want normal. And then again, the default is standard normal, so we can just use the test statistic as the cutoff. So we had a two-sided alternative. We need 2 tail, and then 2.1828 was the test statistic. Since that's positive, that's going to be the cutoff on the right tail. So again, StatKey is going to round that to 3 places and the cutoff to 2.183. And it looks like what we're getting for a p-value is 0.03 when you add those 2 tails together. Next is finding a critical value from a t-distribution. You really only need 2 things for that. You need the confidence level and you need the sample size, because the degrees of freedom will be the sample size minus 1, just like it says in that second bullet point. So to get that critical value, under theoretical distributions, we need the t-distribution with 53 degrees of freedom. And then if I select 2 tail, then since it's 90% confidence, I have to change this central region to have a proportion of 0.9. And there's the critical value, 1.674. Going back to this slide for a second, the only reason the endpoints are there at the bottom is if you wanted to check the algebra just to make sure you're doing things right. The other thing that you might have to do is get a p-value using a t-distribution. You'll have to specify the degrees of freedom right off the bat again. So here, since n is 109, the degrees of freedom will be 108. So in StatKey, under theoretical distributions, we want t, and then 108 degrees of freedom since n was 109. And then it's a right tail because there was a greater than the alternative hypothesis. And the test statistic was 2.2227. And it looks like we're going to get a p-value of 0.014.